Hey, and welcome back to Gaming for Tokens. I'm Marshall, and in this episode, we're going to be talking about Debug and Gizmos. So, first off, welcome back to the Unity tutorial videos. I know I've been away for a while. I am trying to ramp back up and start making videos again. If you don't follow the other series that I started, Let's Make a Game, you won't know that this is now Unity 5, and I've switched to Unity 5. I will be doing a video on what the differences are between 4.3 and 5. I believe I was using 4.3 before I was using 5. Either way, I will be making a video on that eventually here, but for now I'm waiting for them to stop coming up with new features for 5 and things like that and actually get kind of a solid stable out before I start covering that stuff. But anyway, that's a thing for a future episode. In this particular episode, I'm going to be talking, like I said, about debug and gizmos. And what I mean by that is debug, how to do decent debug lines, and how to be able to debug stuff in your code so that you can more quickly figure out what's wrong with it, and possibly even facilitate your design process a little better when you're needing to gather information from the data that you're entering. That'll make a little more sense once we get into this, but it's pretty low level stuff, and I feel like it's something that I wish I would have learned a lot earlier, so I want to try to cover it earlier rather than later. So I've gone ahead and I've already made the script that I'm going to be walking you through making, and I'm going to show you what it does first. I'm going to delete it, and then I'm going to remake it from scratch and go over each step of why I did it. First things first, though, I can't show you what a debug thing is quite yet until I get into the example. I can show you what a gizmo is right off the bat, though, because you've been seeing them the entire time you've been using Unity, whether you've wanted to or not. And I believe in the first Unity video I covered a little bit about what gizmos were. That's what this little tab is right here. This is gizmos. This is all your gizmo control, and if you notice, if you drag this up and down, you'll see that it controls those things, the little camera and sun icon for the directional light and camera in the scene. These little icons are what are gizmos. There's other ways to make gizmos, like debug gizmos and things like that, but these are two gizmos. So gizmos are things that you view in editor that signify a type of object, or like the size of an object or anything like that. Anything that you define it as is what it'll signify. So it's entirely up to you. This little guy right here, the movement tool, this 3-arrowed configuration thing is also considered a gizmo. It's a little bit of a different gizmo, but it's a tool, so this just tells you where you're going to click on things, right? So it is a gizmo, but it's a different kind of gizmo than what we're going to be making. Point is, those are gizmos. Debug stuff, I believe I've used it in other videos before. It just prints stuff to the console usually, but there are a couple different ways you can do that, and I would like to get into that, which is a great segue into my object that I made. So this is the script that I made over here on the right. It looks complicated, but really it's just a bunch of variables so I can show you the different types of debug stuff. So you're only going to be using or looking at a lot of like a chunk of this at a time. So you'll see that a lot of all of this stuff up to the debug log keys, all of that is to do with the 3 different types of gizmos. So like this is a set of gizmo, this is a set of gizmo, and this is a set of gizmo stuff. And these top 2 options up here are actually just actually I think it's all the outer stuff is one gizmo, and then all the inner stuff is one gizmo. So there's only 2 things, and then these 2 checkboxes up here just check if we're going to render gizmos or not. And then these 3 things are the debug stuff. And then the things down here, I'm also going to show you guys how to do line and ray rendering, just because it's really easy and it's really useful in particular circumstances to be able to do this. So jumping right in, if I click this Draw Gizmos button, you also notice the game isn't running right now. So I absolutely can run this, some of this script while the game isn't running, specifically the gizmo stuff. So if I check that Draw Gizmos, you'll see that these things appeared over here in the view, and that's because I have them both set to wire sphere. So the outer type and the inner type are both set to wire sphere. If I change the inner type or the outer type to solid sphere, I get a solid sphere, and I can also change the color to whatever I want the color to be. Here I have my little color picker, and I can change it to be whatever color I want the outer to be. And I can also change that to being a wire box or a solid box. And you'll notice that the type of object it is doesn't really change the color or anything like that. It's set to whatever I want it to be set to. The outer is pretty much the same. Matrix is something that I will get into later. The inner object is pretty much the same in the way that it functions. It's a solid sphere, then it renders a solid sphere. You'll notice that the inner always renders on top of the outer, and I'll show you how to change that around if you want. I purposely did that so that if both of them were set to solid, I could see the inner and the outer, which is something we can handle algorithmically through code. We can say that, if the outer is set to solid, then we want to render the inside first and then the other, but that seemed a little too complicated for this example, just because I am going to be uploading this script to whatever video is the last in the series. Screw it. I'll just upload it to both. So probably in the description for this video, there's going to be a link to the script that this script, and you can feel free to add it to an object and follow along as I go, or dissect it as you need, or use it as reference or whatever you want. It's effectively a useless script. It's just it uses as many of the debug types as I can think of in one script, and lets you toggle them and mess with all of the stats on them. That's all it is. We also have the size of the shapes, so we can determine that. Yep, that's pretty much that, except for the matrix checks boxes, which I'll get to in a minute. But if you want to see that in action, you might not understand exactly what it means, but effectively what it does is this. I have the object rotated, so this using the matrix allows me to rotate that cube. Without the matrix, it doesn't obey rotation. That's all that does. So if I uncheck the matrix and I rotate this object around, you see I'm only rotating around the center object. If I uncheck that, use inner matrix, which you'll see easier with a solid box. If I uncheck that inner matrix checkbox, it stops using stuff there too. So that's all that effectively does, but we'll get into kind of why it does that in a little bit when I start going over the actual script. And then these things down here, if I open up my console, boop, these three keys down here, everything basically below the gizmo stuff only works when the game's running, so I can just cover up this window down here for the most part, and hit play. And if I click down here in the view and I hit it's set to alpha 1 2 3, which is the 1 2 3 across the top of your keyboard. So if I hit 1, it prints off alpha 1 key. 2 also prints off alpha 1 key, which is a bug in the code. We'll fix that as we go. And then 3 also does that, but it prints an error instead. So those are just the different types, the different levels of debug that I'm going to cover. There are a couple other types, but I don't care about those necessarily for the moment. I figure if you can figure out how to use these and you actually need to use more than this, you can probably figure out what those other ones do. But anyway, so these are the different levels of debug, and I can change these to be, say, I don't know, alpha 9, and then when I change this and I hit 9, it says alpha 9. So yeah, the reason why it's saying alpha 1 for all of them in the beginning is because of a bug, so we will fix that when we get there. So I'm going to close that down, and I'm going to not draw gizmos. I am instead, well, actually, I should have a way of being able to turn these off. Oh, that works. All right, so I'm going to change the inner sphere to have I'm going to make a sphere first off, and I'm going to set it to 1, and I'm going to 0 out the rotation. Why didn't the first one take? There we go. All right, and then I'm going to show you these. I can render a line. Now I can't render a line because I don't have a target, but if I create a new game object, this is another thing I can do. Leave those on. So if I have another game object, I can drag that in as a transform here. And I can move this transform around, and it'll actually it'll draw a line to that transform. Without that transform in this slot down here, which is the game object that I just made, without that in there, it won't actually do anything. So if I hit this, it'll come up with this window here, and I can hit none, and it won't work anymore. So if you're using the script and you're trying to follow along and you don't see a line, that's why. And then the line color just controls you know, the line color. So yeah, that is a effectively think of it like a laser pointer to an object. That's all it is, which is very different than the ray. So I do have a ray that I can render. There's that little blue line there. So if we take the ray direction and we really crank that up and we change the color of this to be something a little more visible, like white, we can render a ray which is always going to be in a given direction, and we can set that direction using this vector down here. So rays kind of have their own reasons for being in debug, but it also lets you kind of play around with the idea of a direction, right? So like you can play around with what it actually means to have a direction vector. It's kind of hard to understand what a direction vector is unless you can actually see it. So this kind of lets you do that. So like, you know, what does a direction vector of that look like? It looks like this. It looks a lot like this. It's huge. So yeah, you can play with that. And I think it's a lot of fun to kind of actually be able to visualize what things are for the first time if you haven't ever seen anything like this. Which I hope you have, but if you haven't, I mean, now's your chance. So, yeah, that's kind of what all this does. Now I'm going to do the scary thing that I said I was going to do, and I'm going to take this debug example script. I'm going to hit delete. It's going to ask me if I'm sure. I'm going to hit OK. And I know for some people that may have been really scary, especially because now it's like, oh my god, there's no script here. We're going to remove that component. We're starting from scratch. So I just have an empty game object in a scene. And I'm going to zero out all the transforms on it, except for the scale, because that would be a bad idea. So there's our object. We're starting fresh. All right. So being we're starting fresh, we're going to go over here and we're going to create a new C# script. Bleh. Bleh. All right. And we're going to name it Debug Examples, which is what I had before. I'm going to open that guy up. We're going to open that guy up. I hope it's opening. Yeah, it's opening. All right, cool. So, oh, is it opening twice now? Oh, good. Oh, joy. Oh, joy. All right. So, let me increase that a little bit for you. All right. So the first thing we're going to talk about, the first thing we're going to do is let's do the debug print lines, because those are the easiest by far. And we're actually going to add a little bit more functionality to those. So we're going to do a public key code. And it's going to be called debug log key. And we're going to equal a new key code. Or wait, no, we're not. No, we're going to equal key code dot whatever you want it to be. These are all just the different keys on your keyboard. If I haven't talked about what key codes are, I believe I did my input video actually. So we're going to start off with key alpha 1 because that's what we were doing before. It seemed to work just fine. But this time the extra functionality we're going to add a public string for debug log message, and it is going to equal you pressed a key, and that's all it's going to do. So we're going to do this again for all 3 levels of code. So I'm just going to copy that 3 times, change this from alpha 1 to 2 and 2 to 3, or 1 to 3. And instead of debug log message key, these are going to be debug warn key and debug warn message. And these are going to be debug error message and debug error key. I said those backwards. That was confusing. All right. So we have our debug log key, our debug warning key, and our debug error key, and then the messages that go with those. So this, we can change this to log you pressed a key, warning you pressed a key, and error you pressed a key. And granted, it's going to say those things, but it's just for example's sake and teaching you guys' sake, I'm putting those in there. You'll see that it's going to be redundant, but you'll see why I'm doing that, I hope. And then we're going to set up our if checks for those things. We're just going to do it write and update. We don't have to if we don't want to, but that's what I'm going to do. So I'm going to say if input dot get key down. Yeah, I guess down. We're going to say debug log. Oh, come on. Debug log key. And then we're going to say debug.log. And then we can say debug log message. And then we can say plus space plus debug log. Oh, come on. Debug log message. Oh, wait. Sorry. No, we want debug.log. Oh, I'm messing up here. Debug log key dot to string. All right, now I'm going to explain all this because I know I just went through that. This line right here is basically saying if our key is down, which should make sense to you guys if you guys have seen the input video, and if not, I'll provide a link right here. But input dot get key down, and we're checking for our debug log key that is going to be set in the inspector on the object. If we're pressing that key down, then we're going to debug log our message, and then we're going to add a space in artificially. And the reason why we do that is because we don't expect there to be a space entered at the end of this randomly. Like, we don't expect the user to do this, right? So we need to add one artificially. It's kind of an interesting philosophy that I heard recently from a programmer, was that it's interesting. It's an interesting mentality as a programmer to think that you are making your code, and if people can't use it, they're dumb. It's kind of a lot of the error around a lot of programmers and programming, it seems. Like, I made this code, look how awesome I am, and look, if you just put a space at the end of this, it's so much easier, so just do that. But that's kind of expecting your user to want or to do stuff that they shouldn't expect to have to do. You know, like, your code should elegantly handle that. So you're writing stuff that is going to facilitate other people, so you should write your code in a facilitating way, is, I guess, my spiel for today. And that's kind of what this is harkening back to. So the idea is I'm putting my message in, but I'm manually entering in a space between the rest of my debug message to kind of separate these two messages out. And well-formatted error messages are my favorite thing in programming, because it actually shows that the programmer gives a crap about what they're doing. It shows that they actually put forth the effort, and it can, I don't know, it can help other people who aren't who don't know what is happening or what's going wrong. Like, if, say, you're working on a collaborative project and you're programming the thing, and then an artist gets a hold of it, and they see this weird jumbled together, poorly formatted error message, and they don't really know how to explain, or they don't know what's wrong, so they don't know if they did something or not. Chances are they could end up spending a lot of time trying to figure out what's wrong on their own because they think they broke it, instead of just coming directly to you. So it's a good idea to format your debug stuff properly and not just say, whatever, good enough, they'll figure it out, I don't have to put forth the extra effort. You should. You always should. Anyway, so that's all this is saying. We can go ahead and actually, I can save this, and we can come in here and we can test it. I shouldn't have any errors. Yeah. We're going to drag debug examples in here, and we'll see that we have our key selections, and we have our error messages, right, which have a default message. So I shouldn't say error messages. We have our debug messages already. So the idea is, if I hit play, and I come down here into the game view, I have to click down in here, by the way, which is what I'm doing, and I hit 1, it says you pressed a key, alpha 1. So great, that's exactly what I wanted to happen. And then, yeah, so we just do that again on the next set of stuff. So I would suggest just highlighting that whole row, copying it, and pasting it down, and then doing it again, because again, we're just gonna change log to warn in all cases, And actually, there's a faster way of doing this if you know how to do a copy and replace all. Great. But you're going to want to do it on a specific area. So, warning, if you think you know how that works but never done it before, maybe stay away from it. I don't know. It's up to you. Experiment away, though. So we have debug warn across the board here, and we're going to go debug error here. Error. Alright, and that is it for the different debug messages. So if we come into here and we hit play, in theory if we hit, come on, yeah, okay, we're going, sorry. If I hit 1, I get, you press the key alpha 1, I should get a warning, and I should get a error. Now, this is where we need the different types of debug stuff, because right now we're just doing a debug.log. So what we want to do is debug.log warning and a debug.log error. So the differences between these is it's mostly all like context highlighting if you at a low level. So if you get a warning, it'll show up. Okay, normal debug message shows up like we're seeing down here, right? It shows up white because I'm using the dark skin. It'll show up black if you're not. There it is. Okay. This one down here will show up yellow, and this one will show up red. The other difference is that the red one, if you have error pause on, will pause the game when it appears. So that's really, really handy if it's actually a crucial error. My point is, you shouldn't just be using the errors all willy-nilly, the debug.log error, because it can pause the game for some of the other people working on your project or for yourself, and then you'll go, why the hell did the game pause? I don't understand. Or like other people will be that way. And typically what it'll turn into is it'll turn into people unchecking this box. And that can be bad because then you're just ignoring errors, and who knows what errors, if they're yours or if they're Unity's. I mean, you don't want to get into a habit of doing that. So if you're going to use log error, use it for things that are actually important, and then use these two for like context formatting. So you can say that like, I have a lot of debug log, I'm going to set one thing to warning so that I can see when it shows up in the spam of log. You'll see what I mean in a second here. I'm going to save this, and I'm going to run this, and I'm going to run it with error pause on. So if I hit 1, I get alpha 1. If I hit 2, I get warnings now that are yellow. And if I hit 3, I get an error. Because I had error pause on, it paused the game. So if I hit 3 again, it won't actually go, but if I unpause the game and hit 3, it will. And it'll pause the game again. This is ideally what we want. And what I was saying before with like the spam and stuff, so if you're constantly getting like a flood, if you're constantly getting a flood of debug every frame because you're doing a bunch of checks, and then suddenly you get a yellow thing, you can see when it appears in the log when you pause the game. So that's really, really handy for seeing how these things appear. You can also filter them by these 3 different checks up here. So this will show only errors, this will show all of your normal debug, and this will show only, this will show only warnings, this will show only normal debug, and this will show errors. So if I'm in here and I hit 3, it'll appear in the error filter, and you'll see the little number up here is 1, 1, and 44. So that means there's 44 of these, there's 1 of these, and 1 of these. And they do, if you turn on all of them, they're like checkboxes, like filters almost. If you turn on all 3 of them, you can see all 3. And I believe by default it's set to seeing all 3. So, yeah. That's, I think, everything I want to talk about the 3 different types of error. There are more, by the way. There's debug dot... There's log error format. There's log error exception, log format, and all this stuff. I believe log format and log error format and log warning format are ways of changing how the format works. I never had a problem with the formatting in it. Like, I just got done doing a whole spiel about use good formatting, and then I have no idea what this does. I've never had to use it. I'm sure it has something to do with like the way that it prints out. So if you select all this stuff, it spews all this stuff out of the bottom down here. I think it has something to do with that, but I have never had the desire to tinker around with it all that much. Feel free to look into it and see what it does, but yeah. The only other type that I saw in here that I'm not going to really cover is the log exception. And it just feeds, you feed in it system.exception and then an object for context. It's going to feed in a special exception warning, and that's all it's going to do. It's kind of advanced, but a warning will effectively get you the same results for beginner level stuff. So, and by warning I mean error. So an error will get you the same results as the exception debug for beginner level stuff. So once you get to a point where you think you might need to use the exception, you can go look it up and see what it does and all that stuff, and be happy that you know what it does, I suppose. So moving on to the next thing, I want to do the debug draw line. So what we need is a couple things. We need a bool, public bool rather, and we're going to use this to say render line. This is effectively going to be a on-off, and we're going to default it to off. So this is our on-off switch for while we're in the editor. We have that little checkbox that turns it on-off. That's what this is. The next thing we're going to want is a color. So we're going to say public color. I don't know if I've ever talked about colors, but I know I've talked about vector 3s, and vector 3s and colors are very similar, except for colors are vector 4s. So like a vector 3 but with a fourth slot. Let me show you. We're going to call this ray color, and we're going to call it color dot, let's do cyan. I like cyan. Alright, so oh yeah, first off, you'll see that you have a bunch of static colors that exist in Unity. So you can access a bunch of default things like gray or gray, because they have the two different types of gray. I think that's funny. And you can access magenta or white or yellow or whatever you want. You can also go with clear. Clear is effectively non-existent. It's there, but it's not visible. It has an alpha of 0. Because a color looks like this. New... Oh, I have caps lock on. New color. Wait. Alright, you know what? Let's just do it here. Equals new color. Yeah. So when we feed in a new color, it takes in a series of float values, and depending on how we do this... Does it not... Oh, it doesn't actually take that. Alright, well, that sucks. That would have been an interesting teaching lesson, but that's fine. There are other programming languages that use color and color 256. And color 256 is a different type of color. I think HTML and CSS do, and I think Lua does. I could be wrong with that. I'm probably wrong about that, but I know I've used another language that uses color and color 256. Either way, these are going to be float values that represent colors. So you can go 1, 1, 1, 1. And what this is this is going to be white, and it's going to be 100% visible. But if we do this is white at 50% opacity. So this is R, this is G, this is B, and this is the level of alpha channel, or the level of opacity that it is. If you're familiar with Photoshop, you'll understand the term opacity. Basically, think about it like, or well, I guess if you know what the word opacity means, but opacity is the amount that it is there. So if it's 0.5, it's 50% transparent. 1 on all RGB means that it's red, or that it's white, because this is the red channel, this is the green channel, and this is the blue channel. And in RGB values, 100% in all those channels equals red, 0 in all, or white, and then 0 in all of them equals black. So that's what that is. Yep. So this is going to be white and 50% there. But instead, I'm just going to reference a static color, which is going to be cyan, like so. And the next thing we're going to want is a public, public transform, and we're going to call this, actually this needs to be not ray color, this needs to be line color. Yeah. And this is going to be line target. And this is going to be empty. We're just going to leave this guy empty. The reason why we're going to leave this guy empty is because if you remember in the example that I showed, there was an empty slot and you had to plug an object in there, and that would, the line would target that thing and follow it around. That's essentially what this field is what are we following around. Great. So that's all the stats we need for the line. Let's get to making it. So it's really, really easy, and we're going to do it in one line. We're going to say if render line. That's our Boolean that we've created. We're going to say debug dot draw line. Trying to actually, this is a new keyboard. I'm still getting used to it here, so sorry about all the typos and stuff that I'm making. And you'll see here that at the maximum amount of inputs that it'll take, it takes a start, an end, a color, a duration, and a depth test. We're not going to be using all that, but I will explain what all of them are. Start and end, pretty straightforward. The thing you need for a line to exist, two-dimensional line, is 2 points in space. So a vector 3 and a vector 3 are three-dimensional points, so those will be a three-dimensional line. Start and end, it's pretty straightforward. The start is going to be our position, and the end is going to be our target position. That's all it has to be, and that's what it's going to be. Color, again, pretty straightforward. What color is the line going to be? Duration and depth test are confusing sounding, and those are the two we're not going to use for this example. But a duration is how long in seconds do you want the line to display. By default, it is 0, so it'll be displayed for a single frame, which is what we want because we're doing this in update, right? Which is every frame. So we're effectively manually updating this for forever. So, or for as long as we want, as long as this render line is checked. This can be useful for, say, a single line. If you have a function that's only going to be run once and you want to show a debug, but you want that debug to stick around for a while so you can see it in editor or whatever, you can use that duration to say, like, I want this to render for 2 seconds so I know I'll see it, or I want this debug to render for a second so I'll know I'll see it. You just put in a number there. And then depth test, I believe, will make the bool, or if you set it to true, it will actually render behind things in physical space. So it'll render like a 3D object, because normally debug stuff renders in front of everything all the time, which is, I think, more ideal. But the depth test could be interesting if you say you have a lot of debug noise going on in your scene, like you have 100 objects and they're all running all the same debug stuff, and it's all just a huge mess of lines and stuff. Maybe that depth test could be useful. I don't think I've ever used it, but I could see the usefulness in it for sure. Anyway, let's jump right in. We're going to say, for the start position, we're going to say transform dot position. It's pretty easy. And for the end, we're going to say line target dot position, and the color is going to be line color. That's it, sort of. We also want to run it, because we're referencing this line target dot position here, and the line target is an empty variable. We will get a null reference exception for running this line if something isn't in there every single frame, because we're running it every frame. So the more ideal situation is that we check to see if line target is a thing. So you want to say if line target is not null. So we're going to say if we want to render the line and we have if we have a thing that we want to render it to, then go ahead and render that line to it. Yep, that is all that does. And it's going to be something really similar for the ray as well. It's actually going to be simpler than this even. So hopefully this made sense. If we want to render a line, we have a thing to render it to. Draw the line from me to it, and make it this color. It's pretty straightforward. The next thing we're going to do, we're going to copy a lot of this, and we're going to paste it down here for the ray. And we're going to change line to ray in every instance. We're actually going to get rid of that entire transform on the bottom probably. We're going to say render ray color, and we're going to change this to, oh, I don't know, let's change it to magenta. Alright, and this isn't going to be a transform, this is going to be a vector 3, and this is going to be ray direction, and we're going to make this vector 3 dot forward. And while we're at it, we might as well, let's add some more functionality into it. Let's say we do public, bool local. And we'll make that false by default. All right. So this is something that I didn't actually show in the example because it didn't exist in the example. We're gonna have fun doing that one. It should be pretty easy. What it means is that our array check is going to be a little meatier than this line check is. We won't be able to do it all in one line, unfortunately, but that's okay. So we're gonna say if render array. There it is. If we're going to render our array, and this one doesn't rely on anything else, it's all internal, right? It doesn't need an external reference like this one does, the line target. So we can actually get away with not having to do another check there. We can just say if we want to render it, we can render it, because everything we need to render it is within our own script, and it's all variables that we know for sure are going to exist. It's pretty easy to render a array. We just do debug dot draw array, and it actually looks a lot like the line when we start looking at it. It has a start, it has a direction instead of an end, it has a color, duration, and depth test. So it has the exact same number of variables and the exact same type of variables, but that direction is handled very differently, sort of. Instead of being a target, so like we're going to draw a line from this point to this point in space, this says we're going to draw a line from this point out that direction. Direction vectors, again, like I said before, are kind of tricky to wrap your head around at first, but think about it like if you've ever taken a physics class, you've probably talked about force vectors. That's exactly what a direction vector is. They're effectively the same thing, except for I think they're effectively the exact same thing in this particular instance. So if you had a force vector that looked like, or a direction vector that looked like this, this would be up. This would be pointing straight up because it's 1 on the y. If you had this set to -1, then it would be pointing straight down on the -y. So this would be down. Now if you had 1 and, well, now let's do 1 and 1, this would actually be 45 degrees to the right. So this would be, because we're z is forward, right? So we're looking forward and we're looking to the right. So it kind of splits the difference between the two and says that you're looking 45 degrees off center from forward. So you go forward, go 45 degrees to your right, and that's where you're looking with this. So direction vectors are kind of complicated until you get them. And once you get them, you're like, oh, this totally makes sense. But and hopefully if that doesn't make sense to you, it will when you start actually playing around with this script in Unity and actually looking at how the direction vectors point when you set numbers in them. Because it's kind of interesting, because once you see it, you're like, oh yeah, I can get that. Anyway, so that's what it takes. It takes a start, direction, color, duration, and depth. We're going to ignore the duration depth again, just for simplicity's sake, and we're going to say start is transform.position, and direction is going to be tricky, but for now we're going to say ray direction, and the color is going to be our ray color. And it should be that easy, except we have that local thing. So what we're going to do down here is we're going to create a temporary vector 3, and we're going to call this temp ray direction, temp ray dir, and sounds very French. Temp ray dir. Anyway, temp ray direction is going to equal our ray direction, and instead of ray direction, we're going to use temp ray dir. The interesting thing here is that we can set an if statement for if not local, or if actually we want to change that to ray local. Yeah, we're going to change this to ray local. Sorry about that. Just to keep all of these things grouped in the same nomenclature, so that like rays are all grouped together and lines are all grouped together. I don't want like a random local in my variables just because I don't like that naming convention. Anyway, so if ray local, then we're going to say temp ray direction plus equals transform dot forward. So this is kind of where we get complicated with it, I guess. what I'm doing here is I'm taking the our array direction, and I'm saving it in a temporary variable that's going to go away at the end of this frame, and that temporary variable is our temporary dir, and I'm saying that if we want to be local with our transform, because the difference between world and local is, do I want to look forward on the our vector 3 in the world space, so regardless of my rotation, or do I want to offset that by my current forward? Do I want to look forward out of my object or forward in the world? And those are the two different spaces, right? There's object space and there's world space. So this is saying if we are going to be looking at things locally, which is to say I want to see the forward vector of this object, then we're going to base everything off of our forward vector. So, there's not... Actually, I don't think I want to plus this. I think I want to times this by... Do I? I don't remember how I want this to work. I think I do want to... No, I think I do want to multiply it. Anyway, we're going to have to test this a little bit and see how this works. I'm going to test these in a second, so hopefully we get to see if I'm right here. I think we want to multiply it, but I'm not entirely positive. Anyway, the temporary dir is going to be our direction, and then we're going to offset that by our center, or by our forward center. And then we're going to draw that ray, just like we did our line. So I'm going to save this. I'm going to test this because I really want to see if I'm right. I don't know that I am. Oh, and we have... Oh, yeah, we can't multiply vectors. Oh, that makes me sad. All right, well, I'm going to try to plus it and hope I'm right. I don't think that's right, but we're going to give it a shot. All right. So we have all of our new stuff down here. We have our render line, which in theory, if we create a new game object and we slot that in here and we hit play, that line will be rendering to that thing. So there's our line. So again, all I did was create a new game object, throw it in the transform slot that we created for that line. We're good to go. And in theory, the color will change as we set it. So that's good too. The next thing, the thing that I'm curious about, the thing that I want to see, what I want to know, is if our array is working locally or not. So if I take this guy and I rotate it, it doesn't change, right? Because right now it's working on world space and it's going forward. If I do that, it didn't work. Didn't work. Oh wait, no, did it? Oh wait, it might have worked. I don't think it did, but it maybe did. So if I take this guy and I move it up. Oh yeah, see, it's splitting the difference between the two instead of actually doing that. Dang it. Oh well. There's a way to do that. I don't remember what it is. I know that the really, really crappy, meaty way of doing it is to just multiply each individual vector together, which is really, really obnoxious. Dang it. Oh, I forget what it is. It's really late, by the way. I always record late. So forgive me if I'm a little hazy here or there. I will do something. So if you download the script and this part of it is different, that's what I've done. I've made it so that that local thing actually works. But for now, I'm just going to get rid of that because that's crazy talk. I'm going to put my ray direction back into here, and I'm going to get rid of all of that. And I'm going to make this a single line. So the reason why I was gonna be able to support local direction, but I don't think I can do that. Not right now, at least. I didn't do my research on that part. Anyway, sorry about that. That was kind of a tangent, but yeah, if you can figure out a way to multiply those two vectors together or use a matrix, which we'll be talking about in the next video probably, because this is going to be a two-parter if I didn't mention that. All the Gizmo stuff is going to be handled in part 2. If you can figure out how to handle a matrix, then you can do this stuff local to world really, really easy. I didn't want to go into matrices quite yet, so I don't really want to overload you with that. But if you can multiply those two vectors together, and usually that involves like taking the x of one and multiplying it into the x of the other, and then doing the y and then doing the z. You have to do each axis manually because Unity doesn't let you multiply vectors, which is I think it's kind of dumb. I think it should be able to multiply vectors. Then yeah, that'll work. That's an easy way to do local to the world. But oh well. So that's the different debug messages and the lines. And in the next video, I'm going to be talking about gizmos, which is the more meaty, complicated one, because that requires our own for us to latch into pre-made functions and things like that, and having to deal with matrices, like I mentioned, and having to add a bunch more variables and types and use enumerators, and it gets kind of meaty. So hopefully you guys are ready for that. And if so, I will see you in the next one. Thank you for watching. If you have any questions, as always, leave them in the comments below or yell at me on Twitter, whatever you guys want. And yeah, thanks for watching. Bye-bye.